All right, welcome to part two. The website I use to record these only allows you to record 15 minutes at a time, so. Okay, so this third example, as I kind of gave you the indication, this will be an example of how a triangle is not possible. So we have the same ABC. The side across from the A is 7, the side across from C is 16, and they're giving me the measure of angle A is 30 degrees. So how many distinct triangles? So again, I'm going to use law of sines. C is going to be my angle because that's across from the 16, and I'm going to use the 3 and the 70 because they're across from each other. So 7 is over sine of 30, 16 is over sine of x. I cross multiply, divide, and I end up with sine of x is equal to a positive 1.1428, and it goes on for a while. Well, if I take the inverse sine of that, some of you who remember back to our trig days, remember a unit circle can only have a maximum value for sine at 1. And so since a maximum sine can only be 1, and this is greater than 1, if you type this in your calculator the way it looks right now, it'll pop up as an error. And that tells me that there's actually no triangle possible, since sine cannot be greater than 1. So therefore, there are no distinct triangles possible. All right, now there's another formula, like remember, these are all formulas on the reference sheet. So these are not things you're gonna have to memorize. You just really need to understand and know where things are being plugged into what. So law of cosines is also on your reference sheet. I believe it's in the upper right-hand corner of your reference sheet. We are very familiar with finding the 3 sides of a triangle when it's a right triangle only. If we have a right triangle, okay, then we know it's just a squared plus b squared equals c squared. I mean, that's the formula that we all learned in 5th grade and thought we were the coolest thing ever. But as we know, now that we're older, not every single triangle is a right triangle. So this formula, this law of cosines, works for basically any triangle, including a right triangle. So if you know angle A, then that is the corresponding side that it needs to be squared to be equal to. Okay, so that's probably the most important part because there's so many letters here. A lot of times the question is, where do I put what? So if you know angle A and you don't know the side across from it, this is where you're going to put that, where the little lowercase a is. If you don't know B, but you have the angle B, the lowercase b is going to be what you're equal to squared. Same thing here. As long as the angle corresponds to the opposite side of it, that's really the main thing that needs to be in the right place. All right, so let's look at example 1 here. Sorry, I keep clicking around with my little stylus. All right, example 1. We have a triangle, it's drawn for us, and it says LM is 10, LN is 15, and we know the angle 38. Use law of cosines, it even told you what formula to use, to find the third length. So I'm not going to use law of sines. Law of sines is 2 angles, 2 sides. This is asking for the third side, L. So if I want to label this, okay, if I want to label my sides, which you don't really need to, you just need to make sure that L and the cosine of whatever this angle match up at the end. So I'm going to use the letter L, I'm going to use the lowercase so that it doesn't look like a 1 for me. L squared has to equal, I'm just using the formula from the top of the paper, the other side squared plus the third side squared minus 2 times both of those lengths, and then cosine of the 38, because that corresponds with the missing side, the angle of the missing side. From here, I mean, this whole left-hand side, let me circle it in a different color, this whole, whole right-hand side, that can be just typed in your calculator, literally the whole thing all at once if you would like. You just type that all in your calculator in one big swoop. And you end up with L squared is equal to 88.596 dot 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 dot. Don't clear it. Just go right to square rooting both sides from there. And you get 9.4112, and it goes forever. To the nearest tenth, the directions say. So therefore, L is going to be 9.4. And you're done. It's that easy. Literally, the only thing you have to make sure is that the side across from it pairs with the angle that's given. All right, so let's do another example. Find the largest angle possible, okay? And that's a key word right there. So find the largest angle possible. And basically, whatever you solve for will be your answer. So in this case, we have a triangle. Find the largest angle. So now we're missing the angle, but they're giving us the three sides. So 9, 18, 12. It wants the largest angle. And what you probably learned for you guys, it might have been until geometry. Now coming up, they probably learn it in 8th grade in their geometry unit. But basically, the biggest angle is across from the biggest side. So whatever the side, or the angle that corresponds with the largest side, that's going to be the largest angle in the triangle. So we don't have any like ambiguous cases here. You just have to make sure you pick the correct opposite angle to the largest side if that's what they're asking for. If they asked for the smallest side, then I would have done this lower right-hand corner. Or smallest angle, I mean. Okay, so setting up my formula, that means that this side has to be corresponding to that angle. So I'm going to actually have the entire thing equal to 18 squared. And that's going to equal 9 squared plus 12 squared minus 2 times both of those sides. And then I have cosine of the x because that corresponds with the angle of the largest side. So if I clean this up mathematically, 18 squared is 324. 9 squared plus 12 squared, that's 225. And 9 times 12 times 2, that's 216. Solving for x, I subtract. And I will divide by 216 so that I end up with negative 0.4583 repeating, and that's going to equal cosine of x. Just like before, except now I do second cosine, so I'm going to do, cosine inverse. So second cosine, and I'm just going to basically insert my answer in there. I'm not going to round anything. I'm just going to type the whole thing. Second answer. And I get x is equal to 62.72. It says to the nearest tenth of a degree, so 62.7 degrees is going to be my answer for x. That's going to be the largest angle in the triangle. All right, last little topic that we have today, the last question, and then you guys can get working on your homework, is actually the trig formula for area of a triangle. This one also is on the reference sheet, so you do not need to memorize this one either. Now we know way back in the day, area of a triangle is 1/2 base times height. But that height of the triangle, that altitude of the triangle is not going to be always given to you now that you're a little bit more advanced. What is going to be given to you is potentially two sides and the angle in between these two sides. So if you're given the angle in between these two sides and then they ask for the area, it's actually a really simple formula. It's still 1/2, the length of the two sides multiplied together, and then also times the sine of that angle C. You do not need to memorize the formula, you just basically need to know how to substitute into it. So the final example for today, we have a triangle, BAD. It says if BA is 8, AD is 6, and the measure of angle A is 150, so clearly my triangle is not drawn to scale. Find the area. So if it asked for that kind of a question, and they're not giving you the height of this triangle, or I guess technically they give you a base because they give you two of the sides, but they're not giving you the height corresponding with either of those. It's not a right triangle, it's 150 degrees. So you should then go to your reference sheet, And it says that the area is 1/2 the two sides multiplied together. So that's going to be 6 times 8. And then times the sine of the third angle there. Literally. Type it in your calculator. That's all it is. This could potentially be a multiple choice question, I think. It's not telling you units, but obviously area is units squared. So as long as whatever it was, inches, centimeters, it would just be inches squared or centimeters squared or whatever it ended up being labeled in. It's that easy. So hopefully this will get you through some more of the topics that we're unfamiliar to, and I will be back tomorrow.